Hey folks, I'm Ben Laplanche and I'm a product manager at Snyk working on the Infrastructure as Code product. And today I'm going to be talking to you about how to deploy securely using Kubernetes and Terraform. So in today's talk, we are going to cover what do we mean by infrastructure as code. So we're going to introduce that as a concept. We're then going to talk about applications in the cloud and how those two things relate together. We're also going to move on to a couple of short demos where we are going to take a basic application and deploy that to Kubernetes. We're then going to broaden that example and talk about deploying additional infrastructure using Terraform. And importantly, we'll also talk about how to collaborate with security. So let's get stuck in. So what is infrastructure as code? Really, what we're thinking about here is how do I codify all of the resources and all of the networking, all of the different bits and pieces of your infrastructure, such as virtual machines, for example, into configuration files? And what's important about this concept is it allows us to think about it like code. And when we do that, it means we can then introduce additional concepts such as continuous deployment. And we can do that through versioning. And this is really powerful as well because it allows us to introduce things around automation and repeatability as well. And for teams, this really empowers you to use the tools that you would like to do your job. And with the adoption and kind of popularization of the cloud, this has really allowed you to work even faster and using the tools that you want. And that's because the cloud really allows you to do this in a self-service kind of API-driven way. And then leveraging tools such as Terraform and Kubernetes, you can combine the two to develop this experience. Now, we just talked about how you can deploy your infrastructure and think about that like code, but that brings in the question of security as well. And there's a really good quote here from the Capital One incident that happened recently where the financial giant said that the intruder exploited configuration vulnerability. So this wasn't an issue in an open source library or some kind of exploit that perhaps he used to. This was unfortunately a misconfiguration of the infrastructure that allowed that intruder to get in. And it's really easy to do, and it can be done by accident. There's some stats here of publicly available files that we found on GitHub. And what's interesting about these stats is you can see that there's over 2 million files of Kubernetes deployment manifests. There's a lot of doc files out there, and even Terraform is really growing in usage as well. It's about 140,000 plus files. And this is interesting to me because it really shows the adoption and prevalence of these tools being used by people such as yourselves. So when we think about this together, these tools are fueling people on their infrastructure as code journey. You're really able to get into that groove of this self-service, deploying the tools that you need. But we have to consider security as part of this. Now, that raises the question, like, how does this relate to applications in the cloud? Like, what is an application? If we think about what you could consider as the pre-cloud era, developers typically wrote the application. So this nice green box at the top. And what that typically meant was you would write the codes, the business logic that you cared about, and then you'd be working with the IT operations team who owned everything from kind of the virtual machines all the way down the stack to say the virtual infrastructure, maybe even physical hardware. And that'd be more like a staged process. You would write your code, maybe raise a ticket, work with the IT operations folks to then get that code deployed. So there's these very kind of clear handoffs. And typically security would also be a stage at the very end of that process as well. Now, if we think about the cloud era, you can see here that this definition of the application has changed. Development teams are no longer just writing the code for the application. You're also thinking about how am I going to deploy that and how do I want to do that? So you might be packaging that up in a container image. You're probably deploying that somewhere like Kubernetes, and you're likely using Terraform to provision additional infrastructure that you might need as well, such as a blob store or maybe a database as well. So with that move to being more self-service, more autonomous, you have to take on the responsibility of using these additional tools as well. in order to get your job done. And with that broadening of the tool set, of course, there's a bigger domain and there's more complex technologies that you also need to learn and adopt as well. So that raises the question, where does security now fit in this process, especially if we're working in a more iterative fashion? When we think about that, these could be some of the questions that come up for you. So like, as you're thinking about your application, you might be interested in, is my open source dependencies up to date? Do I have any vulnerabilities? Like, how would I know? As you deploy your codes to Kubernetes, like, have I configured my container correctly? Do I need a root user? How would I know whether I need a root user? Like, and what is this load balancer it's asking me about? And with Terraform as well, like, does my blob store need to be readable by the world? Have I done that by accident? And like, have I set up my permissions appropriately? And this is just a flavor of the types of questions that might be coming up for you and things that you perhaps may not have had to consider before. I really like this quote from the fantastic Accelerate book. What they found in their research was that high-performing teams were spending 50% less time remediating security issues by building security into their daily work, as opposed to retrofitting security concerns at the end. And this quote isn't just powerful because it shows how security fits in and talks about how you can be a more performant team, but it really speaks to that essence as well of working more iteratively. So it really brings a lot of the concepts of how we want to work together here, but highlights there's more things that we need to think about. So let's move on to an example. So I'm just going to move over to a demo. So what I've got here is I've got a basic Golang application that I prepared earlier. And what this does is if we were going to run it, it would just say, hello, SneakCon 2020. Now, I've already built this application, so I know this is working and up and running. And previously, before the talk, I have packaged this up into a container image as well. And I've already pushed that to Docker Hub, so I know that bit is taken care of. Now, the bit we need to think about is how are we going to deploy this? We know we're going to use Kubernetes, but what does that deployment manifest look like? So let's go and do some research and take a look. Now, we've gone to the Kubernetes website here, and we have found the basic example that they provide us on how to run a stateless application using a deployment. And what we can see here is they've provided us a basic YAML file for the Nginx container image. So what I've done is I have copied this YAML and I've taken this over to my terminal. So if I just go back here, so what you can see is this is where I grabbed it from and I've just copied and pasted this in. And what I've done is I've changed the relevant parts. So I've decided to call mine SneakCon 2020 deployment. I said I'd like 2 container images, and I have pointed it at the image that I built earlier and published to Docker Hub. Now, as you are looking at this and focusing on the audience, see if you can spot why this deployment manifest is insecure. And please post those questions in the chat, and we can discuss that as we go along. And I'll try and show you what's happening in the demo as well. Now below, I've also provisioned a load balancer. I got that from another example on the same website, and that just allows us to access that application. So now that we have got that bit up and running, what we have done is I've committed all of my code to GitHub. And here is a run of GitHub actions. And what I'm doing is I'm practicing continuous integration and deployment practices here. So I've decided to use GitHub Actions, and I really wanted to bake security into this part of the process. So by working with our security team, we're going to leverage the Snyk product. And specifically what we're doing is we're using the Snyk infrastructure as code CLI in one of our build steps. So you can see here I've got a job called Snyk Kubernetes Security. There's a very particular step here called run Snyk to check Kubernetes manifest file for issues. And what this has done is it's just scanned that deployment manifest that I'd already committed to GitHub, and it's picked up all these different types of issues. You can see there are 5 issues that have been picked up here. So this is really powerful because I'm getting feedback in the development process. Now, we've also done something really cool here, where we're not just able to see this output in the GitHub action itself, but we can also see this surface natively in GitHub. And if we go to the security tab and click on code scanning alerts, we can see these issues have been surfaced here as well. Now, as a developer, I like to use the tools that are familiar to me. GitHub is one of those, so it's really nice to be able to see the information where I'd like it. So let's take a look at one of these. You can see here there's an issue called medium severity and container can run as the root. Sounds a little bit scary. Let's take a quick peek. What this is showing me is that in this section of that deployment manifest file, it's found an issue, and that's something that we need to take care of. So we've now got some actionable security feedback and a list of issues that we want to address. So let's go and do that. So I'm going to go back to my deployment manifest file. Now I'm just going to address that first issue and show you what happens. So I know that to fix this issue, I need to add something called a security context. And the property I need to add here is called run as non-root, and I need to set that to be true. Cool. So I think I've just added the steps necessary to resolve that issue, but I'd love to get some faster feedback. Sure, I could commit these changes and push those back to GitHub, and that would re-trigger that GitHub action, but I'd love to get some faster feedback. And I can do that by going over to the terminal as well. So I'm in the SnykCon 2020 directory, and you can see here I've got my deployment.yaml file. And what I'm going to do is I'm going to use the Snyk IAC test command, and I'm going to run the deployment.yaml file. Cool. So here we've now got 4 issues, and you can see that that container can run as the root user has disappeared. Fantastic. So we know that we fixed that issue. Now, I also want to address these other 4 issues. For the purposes of this demo, I have prepared a patch file just to speed this part up. So I'm just going to apply that patch. Cool. If I go back to the IDE, I can show you what's happened. And you can see, as indicated by my green bar on the left, that with the change control, I've just added all of these additional properties. So if we just make sure that that is saved and go back here, if I now run the Snyk IAC test deployment.yaml command again, perfect. You can see that we've now resolved all of those issues. So let's just take a quick look. I'm just going to commit all of these changes and resolved Kubernetes issues. Let's just push that back up to GitHub. Cool. So let's recap what we've just covered. In that demo, we started from a basic Golang application that we'd written that said, hello, SnykCon 2020. I'd already packaged that up into a container. And what we talked through was how to do the research by going to the Kubernetes website and grabbing that example manifest file. We then tweaked that for our needs by referencing our container image and deployed it. And what we saw was that actually that was insecure by default, and that just by taking a basic example, actually there's some security issues that we needed to take care of. And what I think this highlights is that it's easy to make mistakes. So in our local development, you're able to kind of code and test and iterate locally to get that feedback that you wanted, both for your IDE and the CLI. And that was because the security team had helped empower you with the tools that you needed. We know as well that by committing changes to our SCM, in this case it was GitHub, and then combined with our CI/CD, in this example it was GitHub Actions, but it could be any tool of your choice, we're also able to get that actionable feedback as well on every build using the Snyk CLI. So this really highlights how you can integrate the security tooling into the relevant part of your process, whilst also getting feedback about how to do this. So let's broaden the example a bit. Let's think about how to provision some infrastructure using Terraform. So what I have here is I've got a Terraform file that I prepared earlier, and we decided that on that application, as well as it saying hello SneakCon 2020, we'd love it to display some pictures. So we need somewhere to store those as well. So what I'm doing is I've got the Amazon AWS Terraform provider, and I'm going to use the AWS S3 bucket resource, and I'm going to call that SneakCon 2020 pictures. I'm going to call it the same thing for its name, and in terms of access control, I'm going to set that to be public read write. Cool. So now we've got a Terraform file that has been configured, and that's already committed. So we could run this the same way. I could go and look at getting feedback on this in our CLI process as well, but I can also get feedback in another way. So let's take a look at Snyk itself. So what I've done here earlier is I went to Add Project and GitHub. And we're now looking at the Snyk UI with an imported project. So this is the same repository that we've just been looking at locally. And you can see it picked up both of the files. So if I go to the main.tf, you can see it's found two issues that we need to take care of. And what we're really looking at here is we're looking at a version of the file that's just been refetched from our GitHub. And one of the issues that's been picked up is around the access control. And it says here that the public read-write is of particular concern. And when I click on that, it gives me some additional information. And we can see that the issue is the bucket is publicly writable. And the impact of this is that it means somebody could go in and alter any of the data that's in there. But we're also giving actual information on how to address this issue as well. So here is suggesting that you could change that ACL attribute and be more restrictive with that, such as specifying that to be private, for example. So this is really powerful, both as a developer, because you're getting the same feedback that you could do from the CLI, but in a more graphical way. And also, if you're on the security team, you're able to see this information across all of the repositories that might be imported as well on that project page. So let's just recap what we saw there. So we broadened that example to using Terraform, and we saw that you can get feedback by importing directly into the Snyk UI as well. And again, we saw how easy it is to take a basic example and make an accidental mistake. In this case, it was to do with how permissive we were in terms of the permissions. So as a development team, you've been iterating on this application, you've been making some great progress, but it's time to start collaborating closer with security. We've really benefited from some of the tools that they've provided us, such as the Snyk CLI and giving us access to things like the various build processes. But how can we iterate a bit faster and kind of work together? So let's go and take another look. Now, what the security team have advised us after taking a look at this issue is that ACLs on S3 buckets are something that are of particular importance to us at the moment. We've perhaps had an accidental issue in the past where we may have leaked some data or somebody changed something, for example. So we really want to consider this to be a higher severity issue than it actually is at the moment. So you can see here, this is flagged as medium. So what we're going to do as the security team is we're going to go to settings. We're going to go to our infrastructure as code. We're going to go to Terraform. And then we're actually going to increase the severity of this issue. And we're going to change that to be high. And the reason for that is because it will then allow us to do some additional filtering and steps in our build process to make sure that we always capture high issues. So now that we've done that, what we want to do is we have our snyk.yaml file that powers our GitHub actions. And you can see here that it has all of the steps already in it to scan our deployment.yaml file. But the security team are going to allow us to do this for the Terraform as well. So let's go and add that in. I'm going to do that through the terminal. So I'm just going to go to the GitHub workflows folder. And if you take a look here, I've got a similar pattern where I've already prepared a patch file just to speed this bit up. So I'm just going to patch the snyk.yaml file with the snyk.patch file. Perfect, that has worked. So let's take a quick look at our IDE. And you can see here, we now have a new job appeared called Snyk Terraform Security. Now we're going to go a little bit further with this example as well, because again, from talking to the security team, so the developers have understood the importance of some of these infrastructure issues. And what we've decided on is we'd actually like to fail a build if we find an issue. So there's a couple of things we're going to change. You can see here that the continue on error is currently set to true. So we're going to change that to false. And the behavioral change that will mean is that any security issues are picked up will now cause the build step to fail. But we don't want to just fail on everything. At the moment, we want to fail if we only find high severity issues. So we're going to pass in an additional argument as well. And we're going to say we'd like to set the severity threshold to be high. So the combination of these two things means that when we scan that main.tf file for issues, we're only going to display anything that's of a high severity. And if we find anything, courtesy of this line, we'll now fail the build as well. So let's see if that does what we expect. Go back to terminal. Let's just check what changes we need to commit. Perfect. So I'm going to say that we have added in the Terraform scanning. Let's just do a git push on that. So what's now happening is we have added the Terraform step. And if I go to actions, I can go to the Snyk infrastructure as code. You can see I've got the latest build run here. And if I go to Snyk Terraform security, you can see that that is now spinning. And what's happening here is it's pulled down all the images and it's now running Snyk to check Terraform config file for issues. And that hasn't quite. So what this has done is this has picked up that there are two security issues there. And this has still found it as medium. And I am not sure why. So let's just go back and try this again. So let's double check the S3 bucket is publicly readable and writable. Let's make sure that sets high, save those changes. And another way that we can validate this as well is we can go back here, and whenever we make any changes, we can go to our main.tf file, and we can also hit retest. So if I just rescan that now, perfect. So you can see that the S3 bucket is publicly readable and writable. So this is the one we just looked at. So we know from looking at the UI as well that that is now set to be a high severity issue. So let's just do a quick bit of debugging to make sure I haven't made any mistakes. So we've made sure that we've set continue on error to be false. And we have the severity dash threshold equals high. Now it looks like when I made the change, I can still have that in green, which means I've not actually committed that part. So let's just try that again. Perfect. So you can see that I actually missed off that additional argument. So let's just fix that up. We are now filtering on high severity issues. Let's just give that another git push. Cool. So that's committing. Ooh, go the right way. So let's go and have a quick look at this again. So if I go back to actions, you can see the latest commit has come in. I'm just going to filter on the Snyk infrastructure as code security job, and that is running. So we're filtering on high severity issues commit. I can see that is running over here. I'm just going to take a quick look at the Terraform job. So you can see everything is in progress. This looks good so far. The image is being pulled. That's now running. And now we're going to check for any config issues. And here we're still finding that issue. But now what you can see is that build step has failed. So that's gone red. So what that means is that if there was an additional step down here that would have gone on to deploy that infrastructure, you're now prevented from doing that. So let's just recap what we've just seen. So we continue to expand the way that we want it to work to the Terraform files as well. We did that in collaboration with security. It was as a result of that conversation that the development team learned about the importance of different types of infrastructure issues. This particular example was for S3. And the security team bumped the severity of that to make sure that it was getting caught in the process. And you could see that we got that feedback both locally, but also by tweaking the setup of that GitHub action, we're then able to kind of break the build as well. So that's both really powerful developer teams to make sure that you are kind of adhering to the standards that have been set, but also as a security team, you can have confidence that insecure infrastructure cannot actually be provisioned as well. So that concludes the talk. So let's just recap some of the key takeaways from this. Like developers, through working in this more iterative way and using security tools at every step of your development process, you know that your application is secure and ready to be deployed, and you're equipped to iterate quickly and locally with security at every step. Security teams, you have visibility of the security posture of these applications from the Snyk UI all of the way through to kind of build output and even the visibility in GitHub security itself as well. So you have confidence that security is at every step of the process. And together, you're now working together. You know how to build trust and visibility that security is an enabler and not a blocker. So thank you very much for listening. It's been a pleasure to talk through this with you. And if you're interested, here's where you can find the demo.